Hello, Professor. Hope you are doing well. So we're gonna give presentation on technology forces group uh, assignments. The subject is emergency issues of tech analytics 7B02. My team is Major bin Sultana. She gonna cover of the topics of challenge and surprises and future shape predictions. So I'm gonna start with the technological force, AI becoming in agriculture. Selected technological force. We have chosen to explore the technological force of becoming as identified in Kevin Kelly's framework of the 12 technological forces shaping our future. Becoming refers to the constant state of evolution and upgrade that characterizes modern technology rather than viewing technology as finished products. This force emphasizes the perpetual beta state where technology as finished products. This force emphasizes the perpetual beta share with improvements or continuous updates are expected, and yesterday's innovation quickly becomes today's baseline. This perspective is particularly evident in the rapidly evolving field of artificial intelligence agriculture, where systems are constantly learning, adapting, and improving through real-time data collection and analysis. In slide 3, industry or societal area. Agriculture represents a fascinating arena to examine the impact of technological becoming. I selected this industry because it sits at a critical intersection of traditional practices and cutting edge innovation. Agriculture faces unprecedented challenges, including feeding a growing edge innovation. Agriculture faces a global population adapting to climate change, managing resource scarcity, and addressing labor shortages. The relevance of becoming to agriculture is profound. Farm operation must continuously evolve to remain viable with AI systems and connected technologies constantly upgrading to improve productivity, sustainability, and resilience. In slide 4, current findings summary. Our research reveals that agriculture is experiencing a fundamental transformation through AI systems that exemplify the becoming principle. Rather than static tools, farm management systems now operate as dynamic learning that provides continuous improve through data accumulation, precision agriculture technologies have evolved from single GPS guidance to comprehensive system with commands improvement. The adoption of these technologies has accelerated dramatically with market growth projections exceeding 25% annually through 2030, suggesting we are approaching a tipping point in agriculture practice. In slide 5, the slide 5 is, can you change the slide? So challenges and surprises. The investigation has revealed several notable challenges. Foremost is the digital divide between large commercial operations with resources to implement advanced AI systems and smaller farms struggling to access or afford them. This raises concerns about equity and market consolidation. Integration difficulties also persist as many solutions remain soil rather than forming cohesive ecosystem that can truly leverage the becoming principle. A significant surprise has been the unexpectedly rapid adoptions of certain AI technologies by traditionally conservative farming communities, particularly in crop disease recognition and irrigation optimization. Once farmers experience tangible benefits, adoption accelerates exponentially. Another surprising finding is the emergence of farmer-led innovation networks, where agriculture producers actively participate in technology development, creating feedback loops that accelerate the becoming process in ways unique to this industry. The next slides will be continued by my teammate Benjamin Sultana.
Hello, Professor. This side is Majbin Sultana. I'm going to cover the next slide, slide 6. Initial thoughts on results. The perpetual upgrading of agricultural AI systems yields both positive and negative effects. On the positive side, continuous improvement is predictive capabilities has demonstrably reduced resource waste. Studies show 20 to 30% reductions in water usage and 50% decreases in fertilizer application while maintaining or improving yields. Enhanced decision support tools provide farmers with increasingly accurate guidance, reducing risk and improving resilience to climate variability. However, concerning negative impacts have emerged. The becoming nature of these technologies creates dependency relationships between farmers and technology providers, raising questions about data ownership, privacy, and autonomy. As systems continuously update, older equipment becomes obsolete more quickly, accelerating replacement cycles and potentially increasing environmental impact. Moreover, the continuous skills updating required to keep pace with the evolving technology exacerbates workforce challenges in rural communities. In the next slide, future shape predictions. Looking forward, I predict several key developments as the becoming force continues to reshape agriculture. First, we'll likely see the emergence of truly adapting agricultural systems that autonomously evolve in response to changing conditions without requiring explicit programming updates. Machine learning models trained on global agricultural data will increasingly personalize recommendations to hyperlocal conditions, improving efficiency while reducing reliance on external expertise. The becoming nature of agricultural AI will also likely accelerate the shift toward decentralized food production systems. As technologies improve, smaller operations may gain competitive advantages through nimbleness and reduced transportation needs. We may see the rise of networked farms that collectively operate autonomous equipment and share data insights, creating distributed intelligence network that continually improve farming practices across diverse geographies. Perhaps most significantly, the continuous evolution of agricultural AI will eventually transform how we conceptualize farming itself, from a practice of controlling nature to one of collaborating with it. Systems that continuously learn from ecological patterns may have developed regenerative practices that enhance rather than deplete natural resources, potentially resolving the long lasting tension between productivity and sustainability. This represents not just technological evolution, but a fundamental shift in how we approach our relationship with food production and the natural world. Thank you, Professor. Thank you all.
Thank you, Professor. Hope you will like our presentation. So we're gonna show the PPT in submission. Hope you will like it. Thank you. Have a good one.
Have a good day.